Few months back I posted a tutorial on Arduino-based weather station in which I displayed the humidity and temperature values on gauges. The software which you can see is designed in VB.NET. This project needs a computer system to display the temperature and humidity values in real time. So I decided to make another weather station using Arduino dht11, Nodemcu and Blynk application, so that we can monitor the temperature and humidity values in real time from anywhere around the world using our cell phone. So let's get started. The components that we will be needing for this project are: number 1, Nodemcu ESP8266 Wi-Fi module, number 2, 5x7 cm Vero board, number 3, 470 microfarad capacitors. We will need 2 of these. Number 4, female DC socket. Number 5, 7805 voltage regulator. First leg is the input, middle one is the ground, and the third one is the output. Number 6, LED. The longer leg is the node and the shorter one is the cathode. Number 7, 330 ohm resistor. Number 8, female headers. Number 9, the dht11 temperature and humidity module. And number 10, some jumper wires. These components can be purchased from Amazon. The components purchase links are given in the description. This project is based on my previous 2 tutorials. In this tutorial you will learn how to install the Nodemcu ESP8266 Wi-Fi board, and how to download and use the Blynk library, and how to fix the USB UART driver error. While in this tutorial you will learn how to make a power supply for Nodemcu ESP8266 Wi-Fi module, so that it can be easily powered up using a 12-volt adapter or battery. The tutorial links are given in the description. First of all, let's start with a datasheet of dht11 temperature and humidity module. This is the dht11 sensor that we will be using today. This datasheet consists of all the necessary information that you want to know about the dht11, like for example its product overview, applications which clearly explains where you can use this particular sensor, the features, dimensions and product parameters, the electrical characteristics which tells you how much voltage it needs, as it needs 3.5 to 5.5 volts, so this sensor can be easily powered up using the Arduino's 5 volt. Pin description. The dht11 sensor has 4 pins. The leftmost pin, which is the pin number 1, can be connected with Arduino's 5 volt. Pin number 2 is the data pin. Pin number 3 is not connected, while pin number 4 is the ground. So my friends, this is the basic circuit diagram which shows that how the dht11 sensor will be connected with the Arduino. As you know, dht11 has 4 pins, 1, 2, 3 and 4. Pin number 1 will be connected with Arduino's 5 volt. Pin number 2 will be connected with pin number 12 of the Arduino. A 10K resistor is connected with pin number 1 and pin number 2 of the sensor. Pin number 3 is not connected, while pin number 4 will be connected with the ground. Now let's do the same connections on a Vero board. So these are the final circuits that we will be using today with Arduino Uno. Let's have a look at the complete circuit diagram. This schematic is designed in Ksoft Eagle 9.1.0 version. If you want to learn how to make schematics and PCBs, then watch my tutorial. The link is given in the description. The power supply is already explained in my previous tutorial. You can use this power supply to power the Arduino by connecting its output with the VN pin of the Arduino. But I will connect a 12 volt adapter directly with Arduino, and I will power up a Nodemcu using the Arduino's 5 volt and ground. As you can see, the Arduino's 5 volt is connected with the VN pin of the Nodemcu and the ground is connected with ground. All the grounds are connected. dht11 sensor is connected with pin 12 of the Arduino. The TX and RX pins of the Nodemcu are connected with pin number 2 and pin number 3 of the Arduino. So the Nodemcu will communicate serially with Arduino Uno through pin number 2 and pin number 3. Pin number 2 is the RX and pin number 3 is the TX, which will be defined in the programming using the software serial library. That's it. And now let's make a Blynk application. First of all, open the Blynk application. Set the project name as a weather station. Click on the choose device and select a Nodemcu. Make sure you set the connection type to Wi-Fi. Then click on the create button and authentication token will be sent on your email ID, which will be then used in programming. Simply copy and paste it in programming. Click on the screen and add 2 gauges. Click on the first gauge and change its name to humidity. Click on the pin and select virtual and also select V2. Set the maximum value 100. Change font size. Click on push and select 1 second. Now repeat the same steps for the other gauge. Now simply rearrange the gauges and change the color if you want. Our basic application setup is completed. Now let's discuss the Arduino and Nodemcu programs. First, let's discuss the Arduino programming. First of all, make sure that you download the DHT library. #include dht.h. #include means that it's a preprocessor directive and .h means that it's a header file. #include software serial.h is the library that will be used for making a serial port on pin number 2 and pin number 3 of the Arduino. Using software serial library, we can define multiple serial ports. Software serial Nodemcu 2, 3. 2 is the RX and 3 is the TX. Define DHT pin 12. dht11 sensor is connected with pin 12 of the Arduino. Uncomment whatever the type of sensor you are using. The dht11 can read only positive temperature. If you want to read a negative temperature as well, then you should go for dht22. Initialize the DHT sensor for normal 16 MHz Arduino. This flag will be used to stop the unnecessary repetition of code. Integer relay is equal to 13. You can also connect a relay with pin number 13 of the Arduino to control a fan. These are the two variables of the type integer which will be used for storing the sensor's data. Integer is data1 is equal to 0. This will be used for storing the humidity value. Integer is data2 is equal to 0. This will be used for storing the temperature. String CData. CData is a variable of the type string, which will be used to store the complete message consisting of the sensor's values. As you know, my friends, every Arduino and Mega program has at least two functions, which are the void setup and void loop function. Void means that this function is not returning any value, and the empty parentheses means that this function is not taking any arguments as the input. Serial.begin 9600 activates the serial communication at baud rate of 9600. This will be used for the debugging purposes. Nodemcu.begin 9600 activates the communication with the Nodemcu at 9600 baud rate. dht.begin activates the dht sensor. Pin mode 4 output dht11 VCC pin is connected with pin 4. I am giving 5 volt to the sensor through pin 4 of the Arduino. This way I can turn on and turn off the sensor. If you want, you can connect this with 5 volt of Arduino. Digital write for high. Then starts a while loop function. Wait a few seconds between measurements. 2 seconds delay. Reading temperature or humidity takes about 250 milliseconds. Sensor readings may also be up to 2 seconds old. It's a very slow sensor. These instructions are used to read the humidity and temperature values. Check if any read failed and exit early to try again. These conditions are used to control a fan automatically. When temperature is greater than 32 centigrade, then the fan is turned on, and if the temperature is less than 32, the fan is turned off. Is data1 is equal to H stores the humidity value, and is data1 is data2 is equal to T stores the temperature value, and is data2. Then we add all the values and store it in a variable CData. CData equals CData plus is data1 plus comma plus is data2 comma will be used as a delimiter. Serial.println CData. This instruction is used for debugging purposes to see the result on serial monitor. Nodemcu.println CData. This instruction is used to send sensor values to Nodemcu. Then there is a delay of half second. This instruction simply empty the CData variable. Now let's discuss the Nodemcu programming. Before you start the Nodemcu programming, first of all make sure that you download all the necessary libraries and you install the Nodemcu board, and you also install a driver for the USB UART. I have a separate video on this. The link is given in the description. Here's defined Blynk_print serial. This is the authentication number which was sent via email. I simply copied and pasted over here. This is the name of your Wi-Fi, and this is the password. Simple timer. String myString. MyString is a variable of the type string, and this will be used to store the complete message that we will receive from the Arduino, which consists of the sensor data, character or data. This will be used to receive characters from Arduino. Integer first value and second value, third value. These variables will be used to store the humidity and temperature values. This function sends Arduino's uptime every second to virtual pin 1. In the app widget's reading frequency should be set to push. This means that you define how often to send data to Blynk application. Blynk.virtual_write v1 millis divided by 1000. When we divide milliseconds by 1000, we get seconds. We are using 1000 because 1000 milliseconds equal to 1 second. Unlike Arduino Uno and Mega, Nodemcu has also at least two functions, which are the void setup and void loop function. Void means that this function is not returning any value, and the empty parentheses means that these functions are not taking any arguments as the input. Serial.begin 9600 activates the serial communication at baud rate 9600. Blynk.begin authorization, SSID and password. Setup functions to be called every second. Timer.set interval 1000 sensor value 1. Timer.set interval 1000 sensor value 2. Sensor value 1 and sensor value 2 are user-defined functions which are called every 1 second. We can change this time. The number of these functions depends on the number of sensors we are using. Then starts a while loop function. If serial.available equals 0, this means if we have not received any data from the Arduino, then simply execute these functions, blynk.run and timer.run. If serial.available greater than 0, this means if we have received data from Arduino, then what to do? Our data equals serial.read. Read the serial port and store the character in our data. MyString equals MyString plus our data. This instruction means add the received character with MyString and store it in MyString. This condition is used to make sure that the complete message is received. Then we simply divide the entire message into strings L and M. We are using comma as a separator. Then these two instructions are used to convert these strings to integers and store the values in variable first value and second value. This instruction is used to empty the string. These are user-defined functions and we simply use these functions to send values to Blynk application. As you can see, the first value stored in sdata and then the sdata is sent through blynk.virtualWrite function to the virtual pin V2, and similarly for the other function. This is a user-defined function of the type string and it takes 3 arguments as the input, the data separator and index. This function is used to split the string. Now we are done with the programming. I have already uploaded these programs. Now let's watch this project in action. I hope you liked today's episode. Like and share this video with your friends. See you in next episode and thanks for watching.